Greetings and welcome to the United States Transhumanist Party Virtual Enlightenment Salon. My name is Gennady Stoliarov II, and I am the chairman of the U.S. Transhumanist Party. Here we hold conversations with some of the world's leading thinkers in longevity, science, technology, philosophy, and politics. Like the philosophers of the Age of Enlightenment, we aim to connect every field of human endeavor and arrive at new insights to achieve longer lives, greater rationality, and the progress of our civilization. Greetings, ladies and gentlemen, and welcome to our U.S. Transhumanist Party Virtual Enlightenment Salon. Today is Sunday, September 14th, 2025, and we have a fascinating conversation in store for you on 3D printing, additive manufacturing, other related emerging technologies, and their implications for policy. How can these technologies be used to achieve greater abundance for all? Joining us today, in addition to myself, is our Director of Visual Art, Art Ramon Garcia, and our special guest today is Tobias Teufel. He is an entrepreneur, biohacker, drone pilot, and philosopher on emerging technology across all topics. He is also our U.S. Transhumanist Party foreign ambassador in Germany for many years now, and he has a startup that focuses on 3D printing. The English name for it is 3D Printing by Teufel. Here is the website of his startup if you would like to learn more about it. And one other aspect that is notable about Tobias is he and I held a live stream on July 9th, 2019. This was during some of the last days of Google Hangouts on Air, which was a great platform. I am sorry that it disappeared in 2019, but I was able to have some excellent panel discussions and conversations, including with Tobias. And we discussed the state of emerging technologies at the time. We discussed robotics, 3D printing, medical technologies, and generally the state of transhumanism in Germany, how it was not well understood at the time, but Tobias has definitely persevered in spreading some transhumanist technologies and applications in Germany through his startup, through his educational endeavors. And Tobias, welcome. My first question for you is, what has changed in your view during the past 6.25 years since we've had this conversation in 2019?
Thank you. A lot has changed. We had more acceptance of technology, more transhumanist technology. We had also a growth in the German Party for longevity. And yeah, overall, it's just a lot politically for me personally. So yeah, we probably have a lot to talk about.
Yes, indeed. And of course, the German Party for Biomedical Rejuvenation Research has been doing well. It has been running in federal elections for Germany, for the EU Parliament as well. It's been getting several fractions of a percentage point. So not enough to get into the EU Parliament, but enough to get noticed. Felix Wert used to be the chairman. I met with him at the Vitalist Bay conferences in Berkeley, California in May. He and I had a good long discussion at the Longevity Policy Conference, and he said essentially he himself is stepping back from it. He's delegating the leadership to others, but he continues to advise them, and hopefully they will continue to do well. We also had a virtual Enlightenment Salon with them back in May 2024. So in terms of 3D printing, tell us a bit about both your startup and some examples of 3D printed objects, which I know you have available to demonstrate.
Yeah, so from what we talked 6.5 years ago, we talked about printing potentially printing moon bases or metal printing or printing implants. And in the meantime, I worked for a metal printing company. I have acquired a medical implant that would be used in the skull fracture. So it has gotten a long way in acceptance and availability. So this, for example, was implanted in a Swedish university in South Sweden 2 years ago. This one is just an industrial material as replica because it's a lot cheaper. But overall, the moon bases we talked about, this is being tested right now by multiple agencies, NASA, ESA. There's been testing of, there's actually a muon regolith supplement, or yeah, and it's standoff. You can print bias filament by yourself and print it on your home printer. Probably not well, but it's a potential right now to test it out by your own on your own machines and get a feeling for it.
Yes, that's quite fascinating. And we talked also in 2019 about essentially the accessibility of the 3D printing technologies. So there had been some tabletop 3D printers that were available mostly for printing with plastic and printing like small components. What would you say is the state of consumer availability of 3D printing technologies today? And I know Germany is the country with which you're most familiar, so talk about that. But if you've observed any differences in other countries, feel free to comment on those as well.
Yeah, the consumer market is, yeah, accessibility has greatly increased. We had so many technology advancements because back then I just got my own printer, my first own printer, and right now the software is better, the sensors are better, the machines are smarter. They take a lot of the initial guesswork and trial and error out of the problem. So right now, the printers you can buy right now are mainly set up, go through a setup guide that the normal printer tells you what to do, and then you can just hit start and print. So it's gotten a lot easier, especially for beginners buying for the printers. And yeah, so not just in Germany, the consumer market overall is pretty average. Sure, buying power is a bit different from continent to continent, but overall it's gotten a lot more accessible.
Mhm. Yes, indeed. So let me give you an example of some 3D printed artifacts that I obtained a few years ago. And I was in Sacramento, which is the capital of the state of California, in 2021. And I happened to walk in the old part of the city where they had historic buildings next to the Sacramento River. And this 3D printed shop sold me some objects very inexpensively. So this is a hedgehog, plastic golden hedgehog, quite spiky. So it was interesting that they were able to make rather sharp spikes out of plastic. This is a bust of Richard Wagner, the famous German 19th century composer. Quite detailed, quite well done. I collect statuary of composers, so this was a nice addition to my collection. And the largest object that I purchased was this 3D printed model of the US Supreme Court building. Again, fairly detailed with the columns, with the windows, as you can see. And this model cost me, I think, $10. The others were less expensive than that. So I got a good deal for them. Now, would you say today, 4 years later, it would be possible for people to 3D print these at home? Or would the materials still be a bit too much in terms of what a typical 3D printer for home consumption would be able to process?
No, I wouldn't say it's. I have a good idea what material was used. It's biopolymer. It's relatively cheap and easy to print. I sometimes use it for models as well. I also have seen models in Malmö, in Sweden, and Copenhagen, where they printed models of the new city district, city area they wanted to show the public, so they would get an understanding of what the city would look like once this district was built, the New Haven area. And yeah, the material is pretty cheap. Good, the good or the high-end printer does take a lot of the guesswork and the trial error out of it. They are a bit more expensive, so they go for around €1,000, $1,200, and but there's still cheaper ones with great communities. They have been going for 10 years, and people just mod the printers to keep them up to date on a technology level. So yeah, I would say it's possible. Good printers with small build volume, 200, €300. That's possible to get today.
Very interesting. So, yes, that would be accessible to the majority of consumers. Now, what would you say would be the technical skill level needed to both operate those 3D printers and, more importantly, to maintain them over time so that they retain their ability to produce these kinds of objects?
Yeah, the operation and maintenance, that's a bit more complicated. Yeah, that's true. Um, for me, for example, in the time since our last saloon in 2019, I did training as mechatronics with specialty in maintenance of industrial machinery. So for me, it's relatively simple. There are some steps you have to take and consider, but people working on, yeah, overall the community, not just people, the community is a better it's a better way of saying it, works on like guides, videos of on YouTube that teach you how to operate the machines, how to fix small errors. Um, of course, I work more in the industrial with other companies, so they have bigger printers and bigger problems. Then normally it's like a standard machine, your industrial machine. The seller takes care of maintenance or sends someone, a service personnel. But in the private area, it's gotten a lot easier as well because machines take some guesswork out of it. Some even warn you after X printing hours. They say, okay, it's maybe time to lubricate the bearings or any moving parts. Maybe exchange some cooling fans before they fail. So yeah, it's gotten easier. It's still not super easy, and you maybe have to tinker a bit with the machines, but it's doable.
So, would you say it's sufficiently doable for the prospect of mass consumer adoption? We have this comment by Michael Lazine, who writes, I would say here in the USA, 3D printing has a long ways to go for the average person to care about using the printers. It seems like DIY people would care more about it. But if, let's say, a layperson did care about it, do you think right now it's possible for them to just set one up and use it if they have, say, $2,000 as a budget for getting a 3D printer, getting the materials, getting any tools that they would need to run it effectively?
Oh yes, absolutely. I would even put it at €1,500, maybe even. And sure, the material is one of the big problems. If you want models, statues, small parts in the house, then you could get away with relatively cheap and easy to print materials. I print more of the industrial style, like these drones, for example. They are carbon fiber reinforced, so you need to upgrade parts of the printer. It's still easy to do, it's a changeable component, but that costs more, the material costs more per kilogram, and so it adds up. The good thing is, because the community is more like this open source idea behind it, a lot of people, myself included, post 3D models of things. For example, I printed some parts for my mother's camping van. So she needed them. I designed them, printed them, and after all, it was sure, I have a business, but my business is in B2B area, so B2C is not really my business. I don't make any money there. So I have no problem uploading my files, my designs for free on the internet for other people to use. And a lot of people think like this. So just I solve this problem for myself. The majority don't have a business. It's just like private users, tinkerers. They upload the files, make them available, and everyone else can download it. If it's a more popular part, maybe there's someone else giving advice in the comments or giving feedback how to print the part properly. And that makes it fairly usable. Sure, designing your own part, that's another skill level. That's a lot more effort. I have been designing my own parts for 9 years now. Probably the same time I have been 3D printing. And I've gotten pretty good at it, I would say. But yeah, simple parts you can learn in a weekend or a week maybe. Complex parts, spare parts, industrial components, that's a bit harder. But anything in the home, you can learn in a week or two.
Very interesting. Yes, and this does give a good idea of the amount of learning and self-education involved. Daniel Tweed writes in our chat, he would say the difficulty level is about like keeping fish in a home aquarium. Would you agree with that?
I haven't really kept fish at home, but yeah, I would say it's regular. You check in on it, control something, keep it alive in this way, and maintain it. So yeah, I would say it's probably the same difficulty level. Yeah.
Yes, yes, indeed. And we have a comment from Mo Guga who says sharing parts for free within the community is awesome. And yes, we applaud the open source ethos that you described, Tobias. And since you've shown the 3D printed drone components, Jason Geringer has a question along these lines. What about 3D printing of drones? How much of a drone can be 3D printed? He assumes the motherboard can't be 3D printed, but it would be interesting to get your thoughts on that. And he also was thinking about how much it costs when creating a drone. How much money is the motherboard and parts that can't be 3D printed compared to what can be 3D printed?
Okay, yeah, that's let's start with what can be printed. It's pretty much this, all the black and white parts. These standoffs are metal and the screws. So any electronics, wiring, there are attempts to 3D print electronics, but this is relatively early and the resolution is it's possible, but it's not like the PCB we have today with thin traces and high component density. It's pretty early. Maybe give it like 5 to 8 more years, and it could be potentially work. But yeah, it's the frame, all the mechanical parts you can 3D print. This, for example, is my design for a drone. It's not optimized yet. I'm just trying to fly it a bit. If it doesn't crash, I try to optimize it and upload the parts. This one too is for free on my design page, so people could download it, print it, and have a fly it.
Excellent, excellent. So your design page, it would be accessible from the website of your startup here?
I'm not sure. I can post the link here. But yeah, it's the 3D Druck by Teufel name. Pretty YouTube printables. Pretty much
All right.
anything.
Mhm. We will get that link shared with the audience shortly. And now we have a question from Art Ramon. He says he needs to 3D print soffit covers, which are vent hole covers, screen light to keep bees out. Art Ramon, perhaps you might want to elaborate on that and what you're looking to achieve here.
Yeah, it's the on the side of the house along the soft area, they have these vent holes. And I tried to find something I could just stick in there and be at the screen, and I could not find anything. So that would be like one application where I could use it to create a custom part, because I couldn't find anything on the internet that was the correct size. What I found was like an aluminum one, but it was just a slightly bit larger. And this would be like a screen case. So it has to be a screen because that's how hot air gets out of there, out of the attic. But it also has to be, small enough to keep bees out. Otherwise, you get bees in there and they'll make a hive. So yeah, that's how I would use it. Yeah, is that easy?
It's possible. Earlier this year, I've been to the conference for content creators, and there's one content creator. I'm not sure if you can see it. It's Kaizen 3D, and he has some textured print plates. That's why it is like all reflective. But there's a mesh in here. So this
Okay.
one is like the first layer. He said he stops the print, puts on some nylon mesh. So this is less reflective. So some nylon mesh, and then puts it in, weighs it down with magnets, and then continues to print. So I haven't tested this. I haven't really find a good application, but yeah, that's the idea. On continue print. So maybe design it, print the first layer, add to your mesh, and then print the rest of the cover.
Okay. I did buy some screen, which I had to put on the outside. I couldn't fit it into the hole, but it just doesn't look very pretty the way I did it. But I had an animal get into the attic, and I didn't know what it was. And it was scratching out all of the mesh from the inside, like a whole bunch of them scratched it out, trying to get out of there. But it kind of created a mess up there. Yeah, that's been a very difficult part to find. So this is where I would see, a nice custom part that I could use. But I need a cheap printer. I don't want to spend too much either. So is there like $500 printer that I could buy that maybe create this custom part?
Yeah, of course. There are some. If you want, if you have some time on the Discord, we can talk it out because
Okay.
it's it's like budget, application, your needs, your skill level, and yeah. But if everyone is on the Discord, feel free to ask me around for a printer recommendation for your application. Happy to help you out.
Okay, and also about how to design this part, the application to actually, I would have to take measurements of the hole and whatnot. What sort of application could be done or is or normally used? Uh, More like,
Yeah, there are some free programs you can use. We use, for example, Tinkercad. It's an Autodesk product. It's also web-based, so any laptop or tablet can run it. And this is like a good entry model program. You can add geometries, subtract geometries, rotate them, change their volume or length, and it's relatively easy to get into. It's not that detail oriented or high precision as you move the parts around and more or less guess where they're going. Most Autodesk or like Fusion, I personally use Fusion for my own business, has student license or private owning licenses, so you could get one of these for free. YouTube has a ton of videos. I learned it myself there, and after all, I'm on the Discord. Happy to help any questions if something comes up. Just the time difference is a bit of a problem. So if someone asks me and it takes a couple of hours, it's probably nighttime in Germany.
all right, thank you.
All right, thank you, Art Ramon and Tobias. Our next question is from Jason Geringer. Can Tobias speak about the technology with regard to 3D printing metals compared to plastic and other materials? What is available for 3D printing of metals today?
Okay, that's I can tell you a lot about the process at the company I worked with. It's pretty advanced, but overall there's the plastic you just heat up either by a heating element, or there's also a powder bed system. You lay down a layer of powder, you use a laser to melt the part you want, or the layer of the part you want, add more powder, laser another one, and this is with nylon mainly, so plastic powder. You can upgrade the power of the laser and do it with metal. That's SLM, selective laser melting. And there's also 2 other versions to make metal. It's LMD. It's laser. It's basically a welding robot creating a 3D part by just laying down welding material. And the other part is the company I worked for. It's similar to welding, but instead of like a welding rod you put in, it's a powder and a high power laser. So you would push the powder with a protective gas or shielding gas into the focal point of the laser. Like if this would be a part, you would melt the focal point above the material and then have molten material drip onto the part. Or like drip, just have it stream onto the part. So that is called ELA. It's Extrem Hochgeschwindigkeits-Laser-Auftragsschweißen. It's a relatively unknown process. It's extreme high-speed laser deposition, basically, because you have the melting point above the part. You can print extremely fast. You can print basically anything that is a powder. Our machines, the old company, could print from aluminum up to tungsten carbide. So I'm not sure what the melting point of tungsten is, but it's 3000 degrees Celsius. And yeah, that's a few exceptions with tin, lead, and zinc, because the melting point is too low. They would just turn to gas. But yeah, you could print metals with that pretty fast. You can combine metals. For example, you create a bimetal, like 2 metals of different temperatures or temperature expansion coefficients. You have also in your what called the mechanical fuses in the electrical environment. So if they overload, one metal bends more than the other, or expands more than the other, it bends and opens the line of electricity, and the fuse is blown in this way. So all the coating of mechanical parts you could do with this. It's pretty advanced technologies with a lot of open potentials. I can't really talk about what I see as well is printing metals. I'm not really allowed to talk about that, so you can guess if it's possible or not.
All right. Well, thank you for that answer. And Jason has a follow-up question. He's asking about the shielding gas. Is that used because of heat, and is that replacing the cooling liquid?
It's mainly used for protecting the machine. So, for example, we could print titanium, pure titanium, and if it gets in contact with oxygen, it could explode. So this is to like keep the metal without oxidizing, because it's extremely fine powder. It could oxidize on a short distance between the nozzle and the part. It's like not even an inch, 20 millimeters. And that's the reason you use shielding gas, to protect the part, protect the powder, make sure there's no oxidation. There's still cooling water inside the laser nozzle to keep the entire optic cool. But yeah, shielding is for the metal powder and the part.
Yes, thank you for that answer. And by the way, for those who would like to access Tobias's designs, including for the drone frame that he showed, this is the link. So I will bring it up periodically. And now for the next question, we have actually several questions from Mike Lazine. He wonders, can you 3D print fabric or textile materials for costumes, and any kinds of fabrics for clothing? Is there such a thing as 3D printing of fabric?
Yeah, that's possible. That's also one of this, is like what I showed before of the mesh. This one is like his business card, but Kaisen, Daniel is his name. He's also printing a lot of cosplay parts or customs. Like you could print on this mesh, you could print pretty much anything. You could print like small scales, and because if there are no contact, you can still move them around like a scale armor or futuristic scales alien scales. There's a lot of potential there. I also printed some costumes for friends. So yeah, it's not my main stuff I do because it takes a lot of time. But yeah, it's possible. I can also look for the link of Daniel, and we can add it later to chat.
Yes, we will share that when it becomes available. And in the meantime, here's a comment from Daniel Tweed. He writes, you can 3D print a wide variety of useful, fun, and artistic items. The possibilities are nearly endless, ranging from simple desktop items to complex mechanical models. He recommends searching for ideas to 3D print various items for various applications. So Jason has another question. Have you heard of 3D printing magnets or patterns of magnets? Is that something that can be done?
Yeah, also the magnet part, as I said, can't talk about the details, but the implication is that's probably going to work. As I have lost the
All right.
company, I'm not sure if the actual, like, if it's going to happen right now or it's going to happen in a couple of months, but it's a possibility being tested. Let's say it like that.
A possibility being tested. All right. Well, perhaps we'll check back in a few months' time and see what happens with that. Daniel also writes that Bamboo Labs makes a well-reviewed 3D printer for under $300. Are you aware of this company?
Yes, I am aware. Personally, not a big fan, as they early in the beginning used a lot of open source projects and ideas to build the machine. And after that, like the normal idea of open source is you can use something that's open source, you can modify it, but the spirit would be then that what you modified and learned and maybe improved, you give back to the open source feed. They did not do that, and overall, it's a good company for private users. The Polish printer seems pretty reliable. As business, in especially Germany, I have to, and Europe overall, I have to abide by a lot of regulations for data protection and safety. One would be that the slicing cloud, so the slicing is the project, yes, the turning your 3D model into a file that the printer is actually be able to use. The cloud servers are in Shenzhen, China, so data regulation is, I mean, I'm not allowed to use them. Basically, that's the European answer. We're not allowed to use them. Private users, if you're not working on anything high tech or dangerous, it's probably not a big deal. I personally use the European counterpart to Bamboo Lab. It's Prusa. They're from Prague in the Czech Republic. And they also share the open source idea. They started to build it from the ground up. They're one of the earliest players that still exist, and one of the biggest in the last one that are really big in Germany and Europe. And yeah, Bamboo Lab, good for private users and consumers. I wouldn't recommend them to us to like companies and stuff.
Very interesting. Yes, and I think this is our first foray into policy questions and considerations. So it seems like the EU's privacy protection laws, I presume GDPR, the General Data Protection Regulation, has something to do with this. These laws affect which 3D printers businesses may or may not use. Could you discuss that in greater detail?
Yeah, I can. From like give you a standpoint for what I do normally for companies is I do application engineering, product development. So if a company comes to me, they hand over some part of their product, of the intellectual property, and they either want it improved or modified so it can be 3D printed. And that's basically what I do. It do testing, development of them. So I get handed a piece of the intellectual property and I build on it. And so it's extremely important that it does not get outside to anybody. And yeah, there's a lot of regulation in this area you have to be aware of. Not sure how it is in America, because in Europe we're known for having a lot of regulations. But yeah, it basically is make sure your data doesn't leave Europe. It's saved on European servers, hosted on European servers, and that's the short version. The long version is a really very long version. But yeah, we have a lot of regulation on it, on data, on development, what parts we can use. We have certifications. For example, if there's a company that wants food contact materials, I'm not allowed to 3D print this because of the process. There's still like between the layers, there's pores, bacteria could go in there. I fortunately know a company that is certified, but you need to certify the printer, you need to certify the material, certify the post-processing, and the entire process as overall. So you need 4 certifications, and that's 100 to 120,000 euros to get the certification all done. So, yeah.
That's a sizable barrier to entry, not insurmountable, but it seems what you're saying is 3D printing of food is potentially allowed in the European Union, but one has to get these 4 certifications. There's a high startup cost, and one has to have 3D printers that are specifically configured to that and meet all the relevant safety regulations.
Yes, it's to protect the end customer. You shouldn't want to like injure them accidentally, have parts break off, or cause any bacteria infection inside the parts. So I think it's a good deal. You know, as end consumer, you're protected, and at the same time, as a company, I don't have the certification, as I said, but I know another company that has this certification. So yeah, it's a good barrier to entry for them. So no one is really following them up. But yeah, we all have to play by these rules, have a bit of ease of mind that we're not eating any broken 3D printed parts by accident. And yeah, it's something you probably have to find yourself if you're okay with this amount of regulation. I mean, it's not really a choice if you go into business this way. But I personally am fine with that. It gives ease of mind, and it's a bit more process, a streamlined business and process. I know what I'm allowed to do, I know what I'm not allowed to do. So I just stick to that, and hope I'm good.
So what kinds of food do get created by companies today that are able to satisfy the requirements of these regulations? I assume something like candy would be easier than meat products. I know there are startups in the US that are doing 3D printed meat products, but they're still not widely available to consumers.
Yeah, candy is chocolate, especially, or like a cocoa fat mix. It's that's relatively easy to do with 3D printers, and there's not much of regulation on that. Meat, as you said, is a lot of people work on it. Smaller startups working on their own. But it's extremely complicated. You have to. There's no. You can't buy 3D printers that can print meat. You can't really buy the raw resource. So you have to create a resource, create a process, keep the process safe, and then also build the machine. So you have a lot of areas of expertise you have to cover. So a lot of engineers, developers, and that's means a higher cost. So it's been done. It's not as quick as people hope it to be done, and it's extremely costly right now.
Yes, I believe it. Cost is the main barrier to widespread deployment of 3D printed meat products in the United States. And I do hope they're able to overcome some of those cost barriers soon, because some of the reactionary governors in certain states, particularly in Florida and states of the Deep South, have actually banned 3D printed food preemptively, which I think is tragic, but they've been fed misinformation by conspiracy theorists. And I think the way to counter that is in states where it's not banned yet, to make it widely available to consumers and get people to realize, oh, this is literally biologically identical to meat that's derived in the traditional way. So people would get used to it, people would recognize it's a more humane option, and then it would become more difficult to ban. But in order for that to happen, the costs would need to be lowered. So Luis Arroyo has a comment: cost barriers are a wild thing that holds back progress oftentimes. And yes, that is an unfortunate reality. Now, Mike Lazine asks, can you 3D print out a Twix candy bar? Now, what's notable about the Twix candy bar is it's multi-layered. So it's not just chocolate. It has that wafer inside. It has caramel inside. And of course, I know in Germany, a lot of the sweets are even more creative and more multi-layered than in the United States. I generally prefer the European chocolates, but that's my own personal bias. And yes, some of those can be pretty sophisticated. So if you have multiple layers, multiple ingredients, multiple components, can you 3D print a candy like that?
From my understanding, or how I would think you could do it, is if you have the wafer laid down, you can melt chocolate, so that's just temperature and caramel as well. So it should be possible. It might be a bit complicated to get it covered evenly, but that's just trial and error once it gets to work.
Yes, indeed. And I presume, like with any discipline, any skill set, there are more advanced practitioners that are able to create products with multiple components if they're clever about the sequence in which they do it. Of course, probably 3D printing just a monolithic chocolate bar with some design on top of it is easier than doing something like this with a multi-layered candy. But hopefully there will be some creativity along these lines. Now, the link you shared is to Kaizen 3D prints, and they have some interesting items there. They have buttons of various shapes, interesting luminescent buttons as well. So they're adding different colors, they're adding different luminescent elements. They have magnetic P-flat sheets. So to Jason's question about 3D printing magnets, they do some of that. They have some clothing, they have some fabrics as well, a 3D printed set of floral textiles that are available. So check them out, Kaizen 3D prints. And this is just another illustration of what is possible. Now, Jason has an interesting question here. Speaking of cost, what is the most profitable 3D part to be printed today? Would it be profitable to make a startup that just makes some bracket or some other common part? So I think Tobias may have something to demonstrate to us along these lines. And you can see he has a large number of 3D printed components. We will go through some of them as well. So what is your answer to this question?
I personally print a lot of engineering and machine building companies. So yeah, brackets, covers, anything that moves the material, electronic mounting. So that's pretty useful. What I have, this is my most valuable part I have printed so far. It's a cover for a copper bar in an electric vehicle. So this one was a safety regulation requirement to cover up the copper, so you couldn't touch it with your hand. And this part was also extremely urgency needed. So I had to stop other jobs and push them forward, so the price went up by a lot. And I sold one of these parts, I believe, for like 34 euros at production cost of 5, because I had to push everything aside, delay other projects. So this one was my most profitable part. But yeah, anything machine building, you can print a lot of parts for small businesses. It's probably the sweet spot. You don't have to work with so many people, like the B2C field with end consumers. They should have a bit more money. So and also some technical background. They can tell you what they want. So anything you can print for smaller companies or companies in your region or your area is probably a potentially lucrative option. If someone would give me like idea for a company or for a area of the oil and gas industry, hospitality, something like this, I could probably give you some ideas because I printed a lot for different companies wanting to test out 3D printing and want to have their product 3D printable.
Yes, very interesting. And one suggestion by our viewer 1-1 is that such a profitable part might be a part for printing more parts. So are you aware of components of 3D printers that could themselves be 3D printed?
Oh yeah, I had a printer until last month behind me, and that one was in big parts 3D printed. Any brackets, it was aluminum extrusion, and the rest of the parts was 3D printed. I know that Prusa, the European company, they have been 3D printing parts for their 3D printers for pretty much since the beginning. So right now I have the latest one. That one is high temperature, so you need even higher temperature material. So it's not really a possible idea. So they use sheet metal. But before that, you can 3D print a lot of parts on a 3D printer itself.
Yes, and in this way, perhaps the 3D printing industry could be self-perpetuating, especially if these are parts that are needed to repair 3D printers where some of the parts have malfunctioned or exceeded their useful life. Now, Daniel Tweet writes he saw a YouTube video recently of someone who practically retired 3D printing mailbox flags. So that's interesting. I suppose you could make mailbox flags out of either plastic or metal, depending on the preference, and the plastic ones could even last some time as well. Now, Jennifer Hughes was wondering, what about 3D printing of organs? What are you aware of in terms of that technology? I recall about 13 years or so, there had been advances in 3D printing of hollow organs like windpipes, for instance, and some scientists have worked on even 3D printing kidneys, though that's more difficult. And there have been miniature models of human hearts 3D printed, though not yet a full human heart for transplantation. So what is the state of that technology?
I guessed that this question would come up, so I asked around, and I work with a startup. You could probably classify them as in Barcelona, in Spain. I will also share the link so everyone else can keep up to date. They are working on tissue 3D printing and cartilage. So anything, as you said, hollow is easier to make than this complex organs like liver. It's like the middle, liver, kidney, any biochemical process, but hearts and lungs that do complex processes in the body, those are pretty hard to make, and it's probably gonna take some time until we get them. But skin tissue is probably the next thing that will come up. So skin graft potentially, or cartilage, as I said. Bone is also possible to 3D print right now. It's not really on the stage where you can implant it, but Peak, as I had here before, this one is already implanted in someone, and it's possible today. So implants, they work. Organs, give it a bit more time, depending on how complex the organ is and how complex the function is the organ does. It's probably going to take some time.
Yes, that makes sense. And the website in question is Regimat 3D. It's described as the world's only integrated tissue engineering platform combining bioprinting and bioreactors to create real functional tissues beyond scaffold printing. So thank you for sharing that, Tobias. And in terms of the medical implant that you described, are you aware of whether are currently in use in medical procedures?
Yeah, this one I got from a company that unfortunately went bankrupt last year. It's a German company. They focused on high temperature materials. This is its peak. It's chemically resistant, and it's already used in medical parts, but normally they have been machined conventionally, so that takes a lot of time, and the material is extremely expensive. This one is the industrial version. This costs 1,000 euros a kilo. The medical one costs 1,800 euros a kilo. So you again need the machine that's especially made for the medical printing stuff. You need the material, and the process needs to be certified again to be medically grade and implantable. So yeah, it's possible. It's already a possibility. It's not done that often because you need the specialist with the machines, you need the material. So I know of two universities. One is in London, Sweden, and the other one is in Calcutta, India. Those two companies already actively implant 3D printed implants.
Very interesting. So Sweden and India are ahead of the curve in terms of providing these to patients. And it's interesting, too, that you could have two objects that are very similar in design, but if you call one of them medical, it somehow becomes a lot more expensive just by virtue of having that designation. And I would like your honest assessment. Is there that much of a difference between the industrial grade implant and the medical grade implant? What does the medical grade implant have that the industrial one doesn't?
It's from I visited the company because they went bankrupt, and the founder told me it's mainly the transport and the production. It's technically the same production, the same material chemically, but the medical part or medical filament and its resource gets sterilized and sealed in a lot more complicated ways than the industrial version, and the printer itself is also um, a bit modified to be easier to sterilize, to autoclave itself, and to disinfect it. So it's probably not that more complex. So not like 80% price increase for the same filament just because it's packaged a bit more complex. But yeah, it's some people it's like I would guess the same as in America. Your insurance company pays for it, so as long as they sign it and pay it, you can add a bit on top. The same with defense contracts. You also
Yes.
just, oh, your government is going to pay it, so you just add a few percentages more because they have to buy it from you or don't buy it at all. So
Yes, and sometimes it is indeed those institutional factors and questions of who pays and the incentives that can drive up the prices, but it seems the one material difference is in the sterilization process. So the medical grade implant, they really make sure that it's free of any kind of infection potential, but probably that doesn't justify the entire price differential. And Daniel Tweed writes, he used to buy industrial gases, and the worker there said all the gases were medical grade, but the certification process was the price difference. So interesting discussion again, another policy implication. And now Mike Lazine has a question. What would happen if someone 3D printed a car? How would a person make that street legal? So given you could 3D print with metal, you could 3D print with plastic, what fraction of the components of a car do you think could be 3D printed? And then what would need to happen to enable that car to be legally operable on the roads? Obviously, the requirements may differ by country, but do you think in Germany, if someone 3D printed a car and said, well, look, here are all the components, we're trying to fulfill all the safety regulations, how feasible would that be?
It would probably a lot more feasible in the United States. From my understanding of the requirements, I see some modified cars on social media in America, and they wouldn't be possible in Germany. I already know that, but the one problem is the certification, the German safety regulation for anything that drives on the road. But I know it's possible to print parts. We had the last company, the metal printing company. We talked with Porsche, the German supercar manufacturer, and they wanted to 3D print brake pedals. The thing is again, cost, because the Porsche, the print brake pedal, if that's a bit more expensive on the overall car, costs a couple €100,000. It's not really a big problem for them. But if you have a car like any Ford or VW, you have a lot lower, smaller price margin to add 3D printed parts to the cost. Technically, if you would go for like the hypercar market, I know that not a car guy, I have to out myself on that. There's an American company that already print a lot of parts for their car. It's it's a hypercar company from California. I'm not sure what the name is, but I can try to find it out, but I'm not sure off the top of my mind. It's a hypercar in the same price class as Koenigsegg.
Interesting. Yes, we will try to find the name of that hypercar company in California. In the meantime, Mike Lazine has a comment. He thinks a lot of items that can be 3D printed would come down to whether it's cheaper to 3D print the product or just buy something that's manufactured in a different way if that is cheaper. And yes, you could have mass manufacturing through older processes that could just be more scalable as compared to 3D printing. But it's an interesting question, and I would like your input on this, Tobias. Which components do you think are more economical to 3D print now, such that there could be a viable market for them, versus components that are still cheaper to manufacture in more traditional ways?
Mm, yeah, the problem is still again cost, because you have the raw. If you go, for example, the company I did my mechatronics training in was an injection molding company, so it's probably the most fast spread process of making plastic parts. So in both cases, you melt parts, but with injection molding, you can make dozens of parts at the same time. And because you take, in both cases, you start with the granulated material, but with 3D printing, you turn it into filament or change it into fine powder, and then the machine only makes like one or maybe a dozen if it's a small part at the same time. It takes a couple of hours maybe. While injection molding, you could make a dozen parts in 10 seconds. So, yes, Zinger, that's the company. And yeah, it's hard to scale up. Where I see the possibility of it being useful or more economical is in spare parts. A lot of companies, small printed parts. That's like the main failing point in all the companies I go to. The failed part is some small mechanical part, some end switch, some mount for important sensor. And in the private end consumer market, it's probably also any part, end of life machines, maybe even vacuums that are no longer being produced, and you can't buy parts for them, or you have to buy them in like large orders online. But if you print them, you can have them in your own house in less than a day.
Yes. And I think this is an important insight. So it might not even be something that's routinely manufactured, but it's something that you need to custom manufacture because you don't have a ready supply of it from the original manufacturer. And I have a story along these lines. So my old kitchen cabinets, which came with my house when it was built, they were almost as old as I am, had one hinge that got detached. And so my door was just hanging on a single hinge. Obviously, this was dangerous and I needed to fix it right away. But the actual hinge itself, I looked at it and it said made in West Germany. So this was prior to the fall of the Berlin Wall, and these components were no longer produced in West Germany. So I had to essentially look online throughout the world. I found one instance of this particular hinge being sold on eBay, and I paid $11 for a hinge in order to be able to repair my kitchen cabinet door. And I am sure that a lot of people with older furniture or equipment face that kind of dilemma, and it's a small part. If you can replace the small part, then the entire item might have many more years of useful life. But if I didn't find that one West German hinge on eBay, I might have had to 3D print it because I'm not sure if I could have put up that door otherwise.
Yeah, that might have been a good option to solve the problem. Print your own hinge. And I know a lot of there's actually a few smaller German companies that work especially with old timers, old cars, because again, you don't have really the parts, the body panels are all, yeah, need to be manufactured by small companies that aren't even manufactured anymore. So they often go through 3D scanning and then 3D printing their parts. Of course, it's like a car, and it's again, you can spend a bit more. You can maybe buy your own printer. If it's smaller parts like hinges, then you might need to know someone or already have a 3D printer. That's also where I personally see the future of this entire 3D printer in every house. It's not really feasible, but I see it in more like hubs for maybe a suburb or a city has one hub with different 3D printers. You have specialists working off different machines. You have maybe metal printing. So this hub could cover a region of maybe X thousand people living there, and if they need something, they could reach out and get their parts printed without having to be specialized in this process, or maybe something like the basic 3D printing I do with filament is not viable, that you need to another process, maybe even metal, and then you run into high costs. So that's where I personally see the future, have hubs and yeah, any center and then print there centrally. That's probably where it goes long term.
Very interesting. And Art Ramon has a comment. He has an old Garmin and the cover broke a tab and there are no spare parts on eBay. I have an issue with a Garmin as well. So this is my Garmin watch. It's a GPS enabled watch. And you can see it's not functioning. What happened was it ran out of charge. And no matter what I did to try to recharge it, I connected various charging ports to it and it didn't work. I connected various cords to it because you can see this charging port here. I think something is malfunctioning in this charging port, so it won't properly connect to a charging cord. Do you think that's something that could be 3D printed, or at least in part 3D printed, so that one doesn't have to get an entirely new device for something like that, which I think ought to be a simple fix?
Yeah, that's 100% possible. Sure, if it's an electric problem, then it might not be, but a 3D printed cover to protect the charger, preemptively might have been something, and it's again the link from my site with all the files. You can search there. There's probably something you can download. There's more websites you can look for 3D printed files. And yeah, printables is one big one. Right now, every manufacturer of 3D printers can create their own platform to get their customers bound to their product. But yeah, there's a ton of them out there with free designs you could download and print yourself or get someone to print it for you.
All right, thank you. And Art Ramon, you said you had a question.
Yes. Okay. Like I just said in the comments, I had a problem with a broken cover for an older garment and couldn't find a spare part on eBay. I could buy a whole new one or a whole old one, but I didn't want to do that. Say I went to scan this part. I've seen people use phones and they scan people and create little miniatures of the person. Can I do the same thing with this part? And then how do I fix the ratio in software to make sure it's the correct size in the software? Because then I would need to make sure it's the correct scale, and then I would want to like copy and flip or reverse the intact tab with the broken side. So the scanning part, how would that work?
Yeah, the scanning phones, there are basically two main tiers. It's I know that iPhone 12 and newer have LiDAR scanning enabled, but there's also an open source and free variant with it's Meshroom, the website is called. You basically take a lot of photos, and Meshroom combines them all and tries to create a 3D model out of as many photos as you potentially can provide. And then the scaling is something you can do in the software. So from the Meshroom, you get a 3D model that is just the surface area or the volume of the part. And then in the software that turns the model into the file for the printer, you can do the scaling, rotation, all that. So that might be a first try. I was just looking up if someone else already had the same problem and maybe has the file already.
Okay, thank you.
Yes, thank you, Tobias. And Daniel Tweed writes, there are rigs that let you do 360-degree scans with a phone. So thank you for that, Daniel. And Daniel also writes on 3D printed vehicles. Slate is a new vehicle that is highly 3D printed. And he says, at least with 3D printing, you can get a vehicle or components sooner with no delivery fees. Interesting, though, of course, if the vehicle is 3D printed at the manufacturer, whatever that is, there might still be a delivery fee. Now, one topic that I wanted to discuss with you, Tobias, is 3D printed housing, because that was already beginning when we spoke in 2019, but there have been significant advances in it. So there are now 3D printed home communities in places in the United States and elsewhere. And it is possible to create 3D printed homes which are cheaper and more durable. So if you 3D print with concrete and deposit it a layer at a time, that's a much more durable design than a wooden frame structure, which is what most houses are still. So where do you see the potential for 3D printed housing, and could we mass produce enough housing to effectively solve the housing availability crisis that is spreading throughout the Western world?
Yeah, this good. The problem is with 3D printing, there are houses right now that are printed that are even in nearby to me. I haven't visited yet, but yeah, you can 3D print houses. The problem is then if you come to any window or door frame, you have to reinforce them while printing. But still, yeah, it's the printer itself is relatively big, but still the house is not. Also, you're not going to print like a family home in one go. At a small, anything between a tiny house and a one family house, you could probably print today. And they're also like the printers are just machines. You turn them on, you feed them enough material, and they continue on printing the house, whatever it is. And yeah, and that's one project I already shared it. Perfect. This Tor Alva. It's a tower in Switzerland, I believe. Yeah, Switzerland. And this right now is the tallest 3D printed building in the world. This was printed in structures, prefabricated structures, you could say, and then just stacked on top of each other. That's an option that you could 3D print prefab houses in a way, and then combine them at the end destination. But yeah, multi-story houses are a bit problematic because the concrete needs time to set and dry out and harden. But single-story houses, no problem. You can print them today. You're limited by the space of the printer, so that would maybe need some special modification, but it's possible, yeah.
Yes, thank you very much. And the Tor Alva design is fascinating. Again, I have kept the website link up for a while because I do encourage people to take a look at it. This was unveiled very recently, May 20th, 2025. And it is quite a novel structural design. You can see these diagonal columns, which I haven't seen anywhere else. And the dome for it, if one could call it that, is a very sophisticated geometric design. So definitely a structure that's worth looking into and worth visiting if one is in the area. But this creates some real new architectural possibilities as well with 3D printing. You could have architectural forms that are not possible with other materials, and this could lead to an aesthetic revolution also, just like building with concrete, building with steel led to new designs of structures. The skyscrapers of the 20th century were made possible by these innovations in materials. So now I think a much greater morphological diversity, to use some more transhumanist terminology, may be possible in terms of buildings as well, and morphological freedom for architects. So thank you for sharing that. And for ordinary housing, so the one-story housing is the most feasible right now. And for a lot of places that would be sufficient. So for instance, in Nevada, where I live, most houses have one story. Some have two stories, but generally speaking, people tend to build more horizontal designs, and part of that is the nature of the soil here. Part of that is just there's a lot of space that is available to spread out. And especially for, say, lower income individuals or people who just need a starter home, one-story house is sufficient. So we have a homelessness crisis in the United States. Imagine if a small one-story home, even say 400, 500 square feet, were 3D printed for these people. That would be enough to get them off the streets. That would be enough to get them some decent housing. So do you think, in terms of another policy question, there might be an appetite in some country, whether that be Germany or another EU country or the United States, to actually have a mass 3D printing program for housing that could be cheap enough to 3D print that it could just be given away to individuals. And again, it doesn't have to be large. It doesn't have to be fancy. It would just have to be functional so these people have a place to live.
Yeah, it could absolutely be possible. I just checked the 400 square feet. That's something you could print in less than a day. So one printer, one house in a day. It's absolutely possible. The price of the printer is also not that high. The raw material is it's concrete. It's not sure how the availability is in places like Nevada. Here in Germany we have concrete plants because we built everything out of concrete. But yeah, it's possible. The printer price the last thing I heard was around 100,000 euros. So you could buy the printer, print a small house for the price of the printer, more or less, and then have many more. So for a government or any regional institution or municipality, it it's a solid possibility. The problem again is like finding operators and training, but I would say that's a small, relatively small problem you can easily solve.
Yes. Yes, thank you for that answer. And Jason also writes, concrete seems like it would be a good material to 3D print. I agree. And my understanding is most 3D printed housing today is made out of concrete. It's deposited in layers, essentially. So you see these homes with a kind of layered snake-like texture, and then sometimes they might refine it, or sometimes that's just part of the aesthetic of these homes. But it's a much better material than wood, in my view. And in Nevada, I think it would be a good material as well. It has a lot of structural integrity, especially if you reinforce it. So Nevada is a bit earthquake prone, not as much as California, but there is a risk. So the material we wouldn't want housing to be built out of is unreinforced masonry, so just bricks being laid on top of bricks. But this concrete, because of how it's deposited, is a lot more interconnected. So hopefully those homes will also have a good deal of earthquake resistance. And to your point, Tobias, about the constraints, so educated, well-trained 3D printer operators, especially in a large-scale construction setting, are important. And that, by the way, could be a job of the future. So if people are concerned about AI making certain professions obsolete, well, maybe this is a profession where employment is going to grow and people could consider educating themselves, because I don't think an AI-powered robot is going to be developed anytime soon to operate large-scale 3D printers for construction machinery. And I think this is a worthwhile conversation to have, because we're increasingly going to need to think about which jobs are going to have staying power. And this seems like one of them, which new jobs will emerge that people could train themselves for. So definitely the whole 3D printing industry is a good one to educate oneself on. Now, another constraint, of course, is the will. There's plenty of land in Nevada. About 84–85% of the state is actually federally owned. And if some of that land could be dedicated to this kind of project or privatized and the private entity could build these homes, then there would be plenty of options as to where to build them. It's a question of will, and it's a question of really getting permission or getting such a project through the various processes at the local level and overcoming the political opposition to building new housing. By the way, I think political opposition, especially from local activist groups to the construction of new housing, is the reason for the housing crisis, especially in the United States, but it may exist in other countries as well. It's called NIMBYism. NIMBY stands for not in my backyard. And that's why we have millions fewer housing units than we need. If the NIMBYism can be overcome on a policy level, then all of these emerging technologies, including 3D printing, could readily overcome the shortage. So You've shared another link, Tobias, and we are going to explore that. This is sci-b.eu, but they have some projects for 3D printed houses in Texas. So if you would like to discuss that, I think that would be interesting as well.
Yeah, that's from my understanding, is one of these projects where you would 3D print, I believe it was 100 houses in as fast as possible to help people that have become or have been looking for houses. And I have here's the price. The total cost of this 104 square meter is 1,200 square feet, roughly, from the top of my head, is $23,000. So I would say that's an extremely good price. Sure, it's one story, but it's fast. It's extremely affordable, I would say. I'm not sure what the prices are in Texas or in housing overall, but yeah, it's one of these potential entry-level houses. $23,000 seems like a good price for a house of this size. It's not like even the smallest house. 104 square meters is a lot. The flat I live at right now is just 60 square meters, so it's 800 square foot. So this is a solid idea and needs more investing and testing and more acceptance. Acceptance is, as you said, the main problem right now.
Yes, absolutely. And I'm looking at this page right now. They have some interesting designs. So not just rectangular designs, but some with rounded corners as well for, again, some more morphological diversity. And 1,200 square feet is a very respectable size for a starter home in the United States. I would say if everybody in the younger generation in the US got a 1,200 square foot starter home, there wouldn't be this push for, let's say, political chaos. There wouldn't be the radicalization that we're seeing right now among young people because they would feel like they have a decent chance at prosperity, and they would see these starter homes as a kind of beginning base of operations, and they could build their way up from there or earn their way up from there. But I think it's very important, it's essential indeed, to enable people to have a foot in the door, metaphorically, if they're able to contribute anything of value. Then a starter home like that is a very reasonable expectation. It was a very reasonable expectation and widespread, even say 2 generations ago, for people who were starting out, usually in their 20s. They would get a house of that size, and that was considered a starter home, and then they would move up into a larger house by the time they were in their 30s. But if that could be replicated again, I think that would solve a lot of societal issues, a lot of discontent, a lot of polarization, a lot of perceived alienation in Western countries, and really revive what has been called the American dream. But it really is a human dream. It's an aspiration to have a place of one's own and have a place where one can start to work toward something greater as well. So very intriguing possibilities. Now, there was also a discussion about 3D printing of rocket components. So Daniel Tweed mentions Relativity Space is a rocket company, and he writes the Aeon R engines integrate powder bed fusion with proprietary wire arc additive manufacturing, or WAAM, techniques. So this is a rocket company that is using additive manufacturing. And I see that you've got what looks like a Saturn rocket behind you. So you have some interest in this area. How can 3D printing and additive manufacturing contribute to building rockets?
Oh yeah, that's also a big part. I've been to the Formex. It's a one of the biggest 3D printing trade shows or expos in the world, especially here, the one in Germany. And there's a lot of companies doing metal printing for heat exchangers on rockets, combustion chambers, custom nozzles. Because again, it's any process, be it for metal or plastic, where you have to remove a lot of material in the conventional manufacturing. And so this is like the prime area for 3D printing, where you start with nothing and just add what you need instead of removing a lot. And also the idea for 3D printing that you could make parts easier. So instead of having a lot of small parts you need to bolt together, weld together on a rocket engine, you could simplify it by eliminating all the smaller parts, just printing one complex but automated part. So that is already a big advancement in the 3D printing of rocket engines. And this just, it keeps getting improving. As I said, the metal printing company I worked for, the last contact I heard was from Antop. That's an American company doing simulations for parts. And they also work for NASA. So any heat exchanger or combustion chamber in a rocket that needs to be specialized or needs to have specific parts or material properties in different places could have that with 3D printing. You could automate the change of material in a printer and just make the correct material on the correct place, so you have the most optimized rocket possible.
Yes, indeed. And again, the 3D printing of components could help if there's something in a rocket that is malfunctioning or needs to be replaced. You might not need to go back to the original manufacturer. One of the reasons why the space shuttle program failed, even though it was a great idea to have a reusable launch vehicle, and you can see behind me some space shuttle models as well, it was really a political reason. The US federal government wanted a contractor in every state, at least one contractor in every state for the space shuttle program to create political buy-in, but that distributed the manufacturing and made it a lot more expensive. And if some part broke, you needed to find the exact manufacturer that created that part, and sometimes there would be backlogs or that manufacturer wasn't in a position to create it. So it became very cumbersome and expensive to maintain the space shuttles, and that's a shame. But what if the space shuttle program weren't discontinued? In my view, that was an unfortunate decision to end it. What if 3D printing were around to print some of those replacement parts and make the reusable launch vehicles a lot cheaper? I think that might be a future path toward reviving reusable launch vehicles as well. So on the subject of rockets, John H. writes he likes the Saturn V model behind you as well, Tobias. And he also writes in terms of making housing more affordable, making it easier for younger people to afford it. Don't make them go broke with outrageous student debt. So I actually think this is one area where Europe is ahead of the United States, because student debt isn't really a phenomenon in Europe as far as I'm aware. Most university education is either freely available or available at reasonable tuition, and people do not start out in a financial hole in their lives. And I think student debt is a form of indentured servitude. It should be abolished. That is my view. Students should not be getting loans with dubious prospects for repayment, which then cannot be discharged in bankruptcy. But John H. also writes he thinks having concerns about who one's neighbors might be as legitimate, especially for people with children. And I think the approach of building new housing, building new neighborhoods, especially on formerly vacant land, is a good approach to address those concerns. So again, if you take land in Nevada, 85% or so of which is federally owned. You privatize a portion of the land. Maybe it's on the outskirts somewhere, still reasonably close to a population center, to various amenities. And you build a neighborhood of tiny homes there. You 3D print them. Maybe some people there will be formerly homeless. Some people are just starting out, but a person who is more affluent might not be interested in living in a place like that. So you have another neighborhood, but the people in existing neighborhoods wouldn't necessarily be close to it. And there could be other criteria. For instance, the US Transhumanist Party advocates when these homes are created for the formerly homeless individuals, there could be some restrictions there, like no alcohol or drugs allowed in these communities, so that these people have the opportunity to clean themselves up. If addiction issues were a part of the reason why they became homeless, then their supply would be taken away. And instead, they would be encouraged to find productive employment to, again, start rebuilding their lives. I think that's an important component to solving the homelessness crisis. But I think there should be many fewer restrictions on what gets built and where. And although a lot of people bemoan sprawl or suburban sprawl, whatever it might be called, I actually think that is a good phenomenon, because that allows people to, again, live where they choose, and for there to be diversity in neighborhoods. If people want to live in a particular neighborhood with certain characteristics, they could set that up. If other people want to live in a different neighborhood, that's fine too. They can set that up, and new technologies allow for these neighborhoods to be built more cheaply, more efficiently, so that more people have these kinds of opportunities. And again, I'm of the view that if people have more economic prosperity, more economic stability, more potential for upward mobility, they're not going to be as inclined to engage in criminal behaviors or even dissipative behaviors like, say, alcohol abuse or drug abuse, because they have something to look forward to. And I think that's important to consider. All of these vices that we're seeing around us, they're a phenomenon of economic decline. And if we can reverse the decline through technological progress, I think we will be much better off as a society. And Art Ramon says that he wants his yearly dividend of salmon and venison. Is that going to be the new way of administering a universal basic income? Perhaps 3D printing of these meats, so that we don't have to end the lives of any animals for that. But yes, I think we need to consider how to create greater abundance in all areas of life. And I'm interested in your thoughts, Tobias, since you work in a field that could greatly improve abundance through technology. What are some promising pathways that you see in this regard?
um, there is great potential for, on one point, saving a lot of electronic, just the printing of spare parts to make sure that not as many electronics or even cars go to waste, and to extend the life to be still somewhat reliable. This already is potential for economic, like the cost of buying a new car instead of just repairing it. Overall, the medical field, 3D printing of implants, that's something that we could already have more of, in my opinion, and something that has also a lot of potential to save lives the moment we start scaling it up, using it more. And I personally would just, I'm not sure about the American law with that, but in Germany you have verbal or formal contracts potentially with universities. So it's like a organ donor, and my agreement is with the nearest emergency university clinic. Is if something happens to me, test whatever high-tech stuff you have on me. I'm aware of the risk, and if I'm not aware of the risk, this person may judge for me. So if I get into an accident and have to be flown out there, I might get the latest test part and test it for a short time, or maybe it's gonna be a failure. But that's personally something I said, okay, I'm fine with that risk. Testing it, and with organs, it's gonna be a bit longer before we have this. With 3D printed meats, we already have medical parts, medicine, and personalized drugs. It's already something that's more and more common because you can personalize with 3D printing, be it drugs, be it a house, be it any private personal gadget. That's something you could do at no extra cost. And this personalization is already a nice thing you can have. As you said, the housing, that's something we overall should push more for because it has low cost. And the moment you start having the people and the machines available, you could make more houses relatively fast and easily. And I guess that combined with giving people more opportunity and more stability from that point onward, you have your house, you can go into maybe training or retrain yourself because you feel your job may have been lost, so you could have it like as a backup net or just as a new stair point. So that already has a lot of good possibilities you could hope for, we could all hope for and push for in the near future. With the more advanced stuff, that's probably going to be a bit more, a bit longer. But yeah, I see a lot of nice things coming up for us.
Yes, and all of these pathways, they add up, even in terms of what is available today with various replacement parts or houses, even simpler houses. That can add up. In total, that could contribute to some significant improvement in people's lives. And as Jason points out, nothing stops a bullet like a job. So if fewer people are in a financially precarious situation, if fewer people are on the margins of losing either their job or their home, then there won't be as much social unrest or upheaval. And I think the important insight to understand about transhumanists is that we are very pro-social. We are interested in underlying societal stability and good order and peace because those are required for technologies to advance. You don't get a lot of technological innovation when there are violent revolutions, when there's blood in the streets, when there are segments of society that are really feeling discontented and acting out on it. So we would rather alleviate that. We would rather have conditions where these people don't feel that way so that the background stability is there for innovation to continue. Now, Daniel Tweet writes, Rocket Lab 3D printing in its Electron rocket for the Rutherford engine, which is considered the world's first 3D printed electric pump-fed orbital engine. So interesting example of 3D printing in rocketry. And Art Ramon writes, what they need is a medical scanner that tells you precisely what one is currently in need of nutritionally and then 3D printing it. So that's interesting. That's essentially getting close to Star Trek replicator territory. So Tobias, when do you think we'll have essentially food replicators in homes or in easily accessible public facilities where you can say, okay, I want this particular dish and it will prepare one for you? How close do you think we are from that stage of the technology?
If you want to limit yourself to pasta and chocolate, you could have it already. Anything more, the food, especially meat, plants. Plants is something you could grow poorly in a bioreactor unless it's algae. So meat is something that's researched. Anything else, not really. So most people ignore it right now. But about the health scanner, I have some good news. I myself moving more as mechatronics, as mechanical and electronics. I'm moving more into embedded systems and variables. So my next job as a research assistant, that's hopefully starting at next month, is in improving or developing the Open Lab project from the Michigan University. So we have been given a grant from the European Union to develop this open source project. This will be starting October. As another part of what I do is developing 3D printed prostheses and developing the embedded systems around it with sensors to maybe not scan everything that's wrong with you, but at least partially something that could be wrong.
Yes, that's intriguing. So, in terms of 3D printed prosthetics, do you think it will soon be widespread, for instance, for amputees to have 3D printed functional prosthetic limbs?
Oh yeah, absolutely. There's a few projects I know of. It's a Victoria Arm. It's a Canadian project. They already do prostheses. I know of a lot of orthesis and prosthesis technicians on LinkedIn that are building out their own labs to have more 3D printing. And yeah, now with the war in Ukraine, there's a lot more in Europe, more development, more people that need prostheses. So there's more of a push for it. And again, it's the strength of 3D printing. You can have something personalized, especially as a patient needs, and therefore hopefully gets soon at a relatively low cost because of the printing process.
Yes, indeed. And here is the website for the Victoria Hand Project. So check that out if you would like to learn about the state of the art in 3D printed prosthetics. And Daniel Tweed cites Captain Jean-Luc Picard tea Earl Grey hot, though that's easy. You can get Earl Grey tea today through a machine. And well, in Europe, it's even nicer. So I've visited Ireland 4 times over the past 4 years, and I've always been fascinated by the coffee machines there because of the variety of caffeinated beverages and non-caffeinated beverages as well that you could have created for you at the push of a button. And I think for Europeans, that's pretty routine now. So they're surprised at how surprised I am by the availability of these. But yes, these are high quality coffee machines. The ones in the United States are very rudimentary compared to what exists in Europe. But yes, you can get Earl Grey tea and other kinds of teas as well from various machines today. I don't think you need to 3D print tea, though. I think simpler technologies can get you to the point where that's pretty much, if not instantaneous, then very quick. Jason Geringer writes Earl Grey is his favorite tea, and Daniel Tweed points out Japan has an amazing food vending machine culture, so perhaps even more advanced than in Europe. And I think we always need to maintain an international perspective on this because a lot of countries have more advanced consumer technologies than the United States now. And we're at the center of the empire. Sometimes people at the center of the empire get this sense of superiority, like nothing can best what they have, but that's actually a very dangerous kind of delusion to be under, because the rest of the world is moving forward, and sometimes in the US, too many factors slow progress down, and we need to identify what those factors are and remove the obstacles. So very interesting conversation. Now we have about 9 minutes left in our salon. I wanted to make sure, Tobias, that you showed us some of your other 3D printed objects that you have available.
Oh yeah, so I have some here. The rest is behind me, the box, the large box. So one of the things that's also from an American university. So in research, America and the United States are still leading in a lot of areas. This is like a compliant mechanism. So by bending this part, these tweezers close. So for example, without hinges, that's extremely new, not really used in anything but research. But again, it's something you could look up the papers, read the papers, and then I bought the book because it's all information compiled. But you could print this on your own printer, test it, and do a little bit of citizen science on your own. And that's one of the nice parts. Again, it's like the carbon fiber reinforced. This one has, you can maybe see it, the black lines here. That's carbon fiber. It's one long fiber. So this part is extremely strong and nearly impossible to pull apart. So this is like the high-tech stuff that's already possible. This one is silicone, 3D printed. Again, this is like the industrial stuff, but it's also used for medical implants or cosmetic surgery. So if you have any, I believe one of the stories on the website is an American soldier who got injured by an IED and has lost part of his legs. So they 3D printed a replacement part to make his leg look normal in apostrophe. So it's something you could use to improve lives today. And I think that's the nice part about 3D printing, that you can get into it relatively easily. The machines are cheaper, it's easier to get into it. And the end is, it's pretty much open. You can do a lot of stuff with it, be it helping your friends, printing customs, or designing your own parts, helping others, printing spare parts. So it's relatively open, and the idea of the open source still is strong there. So I like it. The community is nice, and I encourage everyone, as I said, learn a bit, ask me in the Discord. I unfortunately don't have Facebook, but yeah, ask someone. Happy to help. And maybe there's a few more questions we could answer the rest of the time.
Certainly, certainly. And thank you for showing these additional 3D printed components. It was really a good demonstration of the variety of materials that one could 3D print with now, as well as some of the properties of these materials like durability or flexibility. So this is really quite fascinating. John H. remarks, even current prostheses are light years ahead of the old peg legs, or even the ones in use 20 years ago. So there are runners now who have prosthetic feet, and they can sometimes run faster than ordinary runners with biological feet. So that's interesting too. Even being an amputee doesn't prevent one from being a competitive runner. Daniel Tweed has an interesting comment. He thinks there should be an annual award for the most clever new 3D printed object. Maybe there is one already. Do you know of any such awards in the 3D printing field?
I know there's some events or awards on industrial trade shows, and I know that some, like the website I showed you with my printing parts, they have competitions every now and then where they give away coupons or material, so they're like their own saving points. So there are some, but they're pretty localized to the application or to the potential market. Not like one big where everything is covered. But maybe that's something I don't know, because I'm still like the small niche. It feels like I'm just doing engineering parts for companies with a bit of defense and a bit of medical stuff if the project comes up.
All right, thank you for that answer. And Mike Lazine wonders, what is the biggest size 3D printer available right now? Are you aware of, say, the largest scale at which something could be 3D printed today?
Yeah. The largest printer I know of, it's also in an American university. I believe it's Maine or Michigan. It's a boat. You can print a boat. It's 120 by 90 by 60 feet. So a small boat you can 3D print in a couple of days. That's the top size I know of.
Nice, nice. So if one wants even more abundance and wants to compete with all of the billionaires with their yachts, maybe that's a start to 3D print a boat, and perhaps there will be some larger 3D printed boats available in the future as well. So Jason has a question, and I think this will be a good question to conclude our salon on, since we have 3 minutes. What would you like to do with technology in the future, Tobias?
Oh, that's I personally, as I said, with the prosthesis, I normally print for companies, but I printed for one defense company in Sweden. They're doing EOD education parts. So that was really cool. Just like not just print parts for companies to save the money or make some money, but to actually print parts that help other people. And also with the embedded systems, the prostheses, this combination is one, just good future proving and job stability if it comes up. But yeah, it's just like to do more in education to help people understand. I focus on German, but if something comes up, just ask me. And yeah, just trying to get more people on board, helping them get into 3D printing and getting better at all things technology I come across myself. That's like what I want to do, and then apply it in a helping a good way, to say so.
Yes, thank you very much for that answer. And we wish you all the best in those pursuits, in broadening your reach. Jennifer Hughes says, that is super cool. And also, you shared a link about the open source legs. So there are open source prosthetic initiatives that are happening right now. I think that is highly encouraging to help patients and to bring about this greater merger between humans and technology. It's already happening to a significant extent, of course, with functional prosthetics, artificial organs. We'll be using 3D printing in biological applications, as we discussed, with 3D printing of organs, 3D printing of meat, and in larger consumer applications, homes, vehicles, space travel. This does promise a future of significantly greater abundance, eventually leading to radical abundance. And we would like to thank you, Tobias, for showing us some of the technological possibilities that are available today, some of the objects that already exist, some of the opportunities for people to get involved. This will be an important area for helping us all to live long and prosper.